Hello, Lovelace, and welcome to today's maths lesson. Now, we're carrying on with our comparing of fractions. We're also going to include a little bit of ordering today, so putting them in order based on their size. Now, I know some of us found yesterday a little bit tricky. Don't worry, we'll keep practicing those strategies and those skills, and gradually, I'm sure the understanding will come. But do keep uploading the work. It's the only way I can see which bits of the lessons we're finding comfortable and easy enough, and which bits we're struggling with. If you guys don't communicate with me, then I've got no way of telling how to adjust lessons in the future. Okay, so just keep uploading the work. Even if you've made mistakes, have a go at the corrections, certainly, but keep uploading. Let me see what you're doing. In just the same way as if we were in the classroom together, I could be looking at your books and seeing which bits we're finding straightforward and which bits we're really challenged with. Okay, so it's down to you to communicate, guys. Upload the work. Let me see how we're getting on. But anyway, let's make a start. 3 questions for you initially, just as your little warm-up. Freeze the video. Have a go at these. Right, first up, we've got 4 fractions, and we need to decide which are less than a half and which are more than a half. And if you remember, we mentioned this yesterday as a way of comparing two fractions, to compare them to a half. But first of all, we need to decide if they are bigger or smaller than a half. And the way we do that is we divide the denominator by 2. And by doing that, we can work out what a half would look like with that denominator. So for example, here we've got 6 as our denominator. Now 6 divided by 2 is 3, which means that 3/6 is a half. So we've got 4/6. So 4/6 must be more than a half. Okay, hopefully that makes sense. If we look at 14/29, a bit trickier now, but if we halve 29, we're going to get 14.5. And here we've only got 14. So 14/29 is going to be less than a half. 8/4. We don't even need to think about this one because our numerator is bigger than our denominator. We've got an improper fraction, and an improper fraction is bigger than 1. So it's certainly bigger than a half. And finally, 50/99. Same again, if we just halve the denominator, half of 99 is 49.5. But we've got 50. So 49.5/99 would be a half. We've got 50. We've got more than a half. So that goes over there. Okay? It's just a very quick way of looking at the size of a fraction, comparing it to a half. So you halve the denominator and then see if the numerator is bigger or smaller than that. Right. 11/12 is greater than what? Well, you've got a whole range of numbers to go for here, because as long as the numerators are the same, then the bigger the denominator, the smaller the fraction. So as long as you've gone bigger than 12, you'd be right. 11/12. Remember, if we cut the pizza into 12 equal pieces or 13 equal pieces, then the 12 equal pieces, they're going to be bigger pieces. So 11/12, 13, or any other number bigger than 13. Okay, so you could have said 11/13, 14, 15, 16, 120 243s, whatever you like. As long as the number is 13 or bigger, your answer's correct. What about this one? We've got 11/8 and we've got 10/4. Which one is bigger? Well, for this, we need to do some equivalent work. We need to convert our denominators so they are the same. And the easiest way, I think, is going to be to work on this one. Turn this one into 8s. So if we do that, double the 4 to get 8. Whatever you do to the bottom, you do to the top. So double the 10 to get 20. So we've got 11/8s, we've got 28s. So quite clearly, the 28s or the 10/4, 10 quarters, are the larger one. Okay, right, let's crack on with today. Here we go. Write these fractions in ascending order. First of all, we need to remind ourselves what ascending order means. To ascend means to go up. Okay, so you might ascend in a lift or ascend up the escalator. Ascending is to go up. So we're going to start with the smallest value down at this end on the left and the largest value up at this end on the right. Now, you'll notice all of our numerators are the same value. So that's going to give us a massive clue. We don't need to do any working out. We just need to look at the denominators. And if you remember, if the numerators are all the same, then the greater the denominator, the smaller the fraction. So if you've got a big number down here at the bottom, then that's actually quite a small fraction, which means that our 5/29 is actually the smallest value. 5/21, 5/11, and 5/6 is actually the biggest fraction, okay? Because we've only split our whatever it is into 6 equal pieces. So each piece is going to be bigger than if we split it into 29 equal pieces. Okay? You'd much rather share your sweets between 6 friends than 29 friends because you'll get a lot more. Okay, so there's our ascending order. Smallest, largest. Okay. Right, same idea, but this time we don't have matching numerators to help us. For this one, we're going to look at the denominators and try and make them the same. So let's have a look. We've got 16, we've got an 8, a 4, and an 8. We're looking for a nice number that all of those values will go into. Well, I think the 16. So I'm going to turn all of these fractions into equivalent 16ths. Starting with this one, 5/8. Well, to turn an 8 into a 16, we're just going to times it by 2. Do the same to the numerator. Okay, so we've got 10/16. What about this one? To turn a 4 into a 16, we multiply by 4. Do the same to the top, multiply by 4. 12/16. And finally, turn an 8 into a 16, we multiply by 2. Multiply the top by 2. 4/16. So these in blue are equivalent fractions. We're now going to use those to put our sequence together. So remember, we've got the smallest on the left. So we've got 11/16, 10/16, 12/16, and 4/16. So our 4/16 is the smallest one, which is our 2/8. So our 2/8 is our smallest value. We've now got 11, 10, 12, 11, 10, and 12. So our 10/16 is the smallest, which is our 5/8. 11 and 12, 11 comes next. And finally 12, which is our 3/4. Okay, so by doing some equivalent fraction work there, this has allowed us to quite efficiently sort out the sequence of fractions. Okay, right. We've got 4 more for you now. Again, look at the denominators. Let's do some equivalent work and see if you can work out the smallest to the biggest. Pause the video, have a think. Okay, for this one, we've got a 2, a 10, a 5, and a 5. We're looking for a nice number that all of these will go into. I'm going to stick with the 10. So I'm going to turn all of these fractions into tenths, into equivalent tenths. We'll start with the half. To turn a 2 into a 10, we times by 5. Do the same to the top as well, and it's 5/10. So there's an equivalent fraction. 3/10 can stay the same. 4/5, well, we're going to double the bottom number, double the top, and that's 8/10. 2/5, again, double the bottom, double the top, and we've got 4/10. So we've now got 5/10, 3/10, 8/10, and 4/10, and we can now put them in order. So our smallest is going to be the 3/10. Our next will be the 4/10, which is 2/5. 5/10 comes next, which is the half, and 8/10 is the largest. Okay. Right. Just a reminder then. I know we've touched on it a couple of times over the previous couple of pages, but just a reminder how we do find an equivalent fraction. All we need to do is the same operation to the bottom number as we do to the top. So in this case, if we want to turn quarters into twelfths, then to turn a 4 into a 12, we multiply by 3. Now we need to repeat that operation. Whatever we do to the bottom, we do to the top. So we've got 3 times 3, giving us 9. So 3/4 is equivalent, is the same size as 9/12. As well as multiplying, we can also divide. We want to turn 15 into fifths. So to turn a 15 into a 5, we're going to divide by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. Okay. So in both cases, because we've done the same operation to top and bottom, we've created equivalent fractions. Now, this is a bit of a tricky one, but what's the missing denominator? Okay. And we're going to do this with equivalent, or coming up with the same numerator to help us compare. So we've got 16/23 and 8/13. Let's make these numerators the same. So 16, turn a 16, all right, sorry, turn an 8 into a 16, we're going to double it. So let's double both top and bottom of 8/13. So we've now got 16/26, which is equivalent to 8/13. So we've got 16/23 and 16/26. And we're looking for a fraction that falls in between those. Well, it's going to be 16 something. So 16 over what? Well, we've got 23 here and we've got 26 here. What numbers fall between 23 and 26? Well, 24 or 25. Okay. Now we need to decide which of those is the best option, because we know the final answer is 2 over something. So we're going to have to be able to simplify this. We're going to have to be able to make it smaller. Now, if we put 25 there, can you think of any number that goes into 16 and 25 to make it smaller? Because I can't. So that's not going to work. But if we put the 24 in, then you can see they're both even numbers. So we can divide and make these smaller. In fact, we can make them a lot smaller. If we want to turn that 16 into a 2, we're going to divide by 8. Do the same to the 24, divide by 8. And you can see that we're going to get 2/3. Okay, so we've been able to work out that missing number using the information around it. That was quite a tricky one. If you've not totally followed that, don't worry. Remember, it's all about just understanding how we can make the denominators or the numerators the same to help us compare fractions. This was just quite a tricky example. Anyway, 2 questions for you to have a go at. First one, there are a selection of correct answers for some of these. So if you can find one answer that would fit in each of these 9 questions, I'll show you all the options, but there is more than one answer to most of those questions. And question 2, Tommy and Eva are comparing fractions. Okay, and they've got their personal methods. Now, whose method is more efficient? Which method do you prefer of those 2? Okay, pause the video, take a moment. Right, so number 1. In blue, I've written some examples of the correct answers. But here's the complete list. So let me explain. For 1A, the only possible answer is 1. For B, if you put 1 or 2, you're correct. For C, any number between 1 and 9 is correct. D, 1 or 2. E, any number between 1 and 8. F, any number between 1 and 5. G is any number between 1 and 8. H, any number between 1 and 5. And I, any number between 1 and 5. So if you've put one of those examples, one of those answers, you're correct. Now, this one was a funny one, because in Tommy's case, he says, when he's comparing these fractions, I found a common denominator of 36 to compare the fractions. So what he's going to do is he's going to multiply up and create equivalent fractions up to 36. So he's going to end up with 24 over 36. He's going to have 24 over 36. And he's going to have 16 over 36. And he's going to compare them that way. So that's one option. Whereas Eva, she's found a common numerator of 4 to compare them. So she's going to say 4 over, 4 over 6. She's going to say, actually, I've just realized what Eva's done. Eva's made a mistake, hasn't she? So even my answer there is incorrect. I apologize. I've just realized what Eva's done. No, I've not. Sorry, I'm getting confused with numerators and denominators. Forget that. So let's get back on track. Eva has found a common numerator of 4. So she's saying that this is going to be 4 over 6. This is going to be 4 over 6. And this is 4 over 9. And that's going to allow her to compare. Sorry, I got myself confused there. Now, as regards which one is best, which one's most efficient, it's up to you. It really is. And let me explain why. Tommy's method does use bigger numbers. He's going all the way up to 36. But all he is doing is multiplication. Okay, so he's just using one operation and making everything that little bit bigger all the way up to 36. So he's using bigger numbers, which some people find trickier. Whereas Eva is using a mixture of multiplication and division. And so she's got to keep on track of what she's doing. She's got to make sure she's doing the right operation, while she is dealing with smaller numbers, though. So it's whatever you prefer. You can see from the confusion I've just created for myself, I prefer Tommy's method. But that's personal choice. Okay. If you're happy with multiplying and dividing in the same calculation, then that's fine. Eva does work with smaller numbers. Tommy works with bigger numbers, but he's just using one operation. So personal choice. Which do you understand? Which do you prefer? There's no right answer there. Okay, right. 2 more questions for today. Number 3, a cluster there of 5 fractions in each question. Can you put them in ascending order, so smallest to biggest? And then question 4, there are 4 possible answers to this. Can you find all of them? Can you find what 4 numbers could possibly fit in there in that number sentence? So is larger than 3/5, but is smaller than 9/10. All 4 possibilities, please. Pause the video, away you go. Right, here are your answers. Now in A, all the numerators are the same. So all you needed to do was put the largest denominator at the left through to the smallest denominator on the right. So the 2/3 is the largest of those fractions. On B, I would be looking at converting the denominators. Okay. And in this case, if we convert all the denominators probably to 18, because 6 won't go into 9. So I might go to 18 to say, convert them all. And then once you've converted them back again, there's your sequence: 1/9, 2/9, 5/9, 2/3, and 5/6. On C, I would definitely be looking at the denominators, and I would be converting them all to 10. So once I'd done my equivalence to 10, I'll be very, very quick to be able to convert them back again to 1/5, 3/10, 1/2, 3/5, and 7/10. And finally, for D, I will be looking on this one at equivalent numerators. So turning them all into 12 as a numerator. And then once sorted, convert them back again. Question 4. For this one, you need to turn all your fractions into 30ths. And then once you've done that, you'll be able to work out what the possible missing numbers are. So let me explain. The 3/5 is the same as 18 30ths. So we've got 18 as a numerator there. 9/10 is 27 30ths. So we've got 18 and 27. So the number in here must fall between, say as 30th, must fall between 18 and 27. But we need to be able to halve it. So the only possibles are 20, 22, 24, and 26. And once we simplify those back to 15ths, once we halve them, Then we're left with 10, 11, 12, and 13. Okay. Right. That's the end of today. Remember the basic rules, though. Always look at a group of fractions and to see, can I easily convert all the denominators to the same number? Or can I easily convert all the numerators to the same number? If you can do one of those, either converting denominators or numerators to the same number, then you can compare fractions nice and easily. But you do need to convert them so that either numerators or denominators are the same value. Okay, with that, I'll bring the lesson to an end. Thank you for listening. Take care of yourself, guys. Get this uploaded so I can see what you've been up to. Look after all those around you. Take care, and I will see you all very soon.